Hello and welcome to this series. In this series, we're going to be building an HD-2D RPG in Unreal Engine 5. Full thing, movement, camera, combat, inventory, dialogue, quests. If it belongs in an RPG, we're building it. Okay, so we're assuming you've opened Unreal before and you know roughly where things are. Beyond that, we're good. We're going to be taking it slow at the beginner pace. This first video, we're getting the project set up and getting a character moving around the world. Boring, a little, important, very. So let's go. Let's do a bit of setup first. Let's create some folders so that we can organize our stuff better and we don't get lost in the content browser. So I'm going to create 3 folders. You can either right click, add new folder, or you can use your shortcut, Shift N, and blueprints, another one, maps, and we're gonna create our first map. Go up to File, New Level. I'm gonna go for Basic, and Ctrl S to save. And in the Maps folder, I'm gonna go Main. So I like to call my first map Main just to have something that works. So the next step would be to create our core blueprint classes. And in blueprint, let's create a new folder, call it core. And in core, I'm going to add 3 blueprints. Now the first blueprint is going to be of type game mode. And let's call it B_JRPG game mode. Next, I'm going to create another blueprint called of type player controller. Let's call it B_JRPG controller. And last but not least, we need a pawn. But for the pawn, we're gonna use a kind of specific class that Unreal has because we're doing this HD-2D JRPG, and we're gonna have these flipbooks that are 2D flipbooks that move in 3D space. And Unreal has a blueprint class that can help us achieve this. So this is going to be paper character, and let's call it B_JRPG. Now we have these 3 classes. Now, if you're new to this, you might ask, what are these classes or what are they used for? These are the core classes that you need to have anything in the game. First of all, let's talk about the game mode. The game mode knows about what player controller you're using, what player class you're using. It's basically your rule book and knows when players sign in, sign out, and stuff like that. The RPG controller, or the controller, it's you. It's not a player. This is basically the interface between you and the character that you control. So these are your inputs and stuff like that. As for the JRPG character, it's the character we're going to be controlling in the world. So let's do a bit of setup. We have created our level, and we need to tell that to this level that we're using this game mode. And if you don't have this open right here, the world settings, you can go into window and open it up with world settings. Now you can see that game mode override is none. So now it's in the default game mode that comes with Unreal, but we do want to set it up with our own game mode. So let's drag first our game mode. You can either do it by dragging the game mode directly on the slot or look for the game mode here. I like to do it like this, so I'm sure that I picked the right one. Now, if I put the game mode, I haven't set up any of these yet in the game mode because the game mode needs to know what player controller and what pawn am I controlling. So to do that, let's open the selected game mode and we can find all the default or all the settings for the game mode here. Now, the two settings that we're concerned with are the default pawn class and the player controller class. So let's drag the controller into the default controller class and our JRPG character into our default pawn class. Now the game mode knows about these, and the level knows about the game mode, and we have something already set up. Let's add something to our scene so we can see our character, because for now it has no shape, no color, nothing. So we need to add some visuals to the character, right? So let's go into art and create a new folder called it hero. And in hero, I'm gonna now add a sprite sheet. Now this sprite sheet, I created it with the website that I'm gonna link down below. It's very useful. You can change your face, the hair, what they're wearing, and it's gonna be the same tool I'm gonna be using to create all the characters that are gonna be in this series. Okay, so I'm gonna drag first the spreadsheet called Hero Walk, and if I open it up, you can see this is how it looks like. We have the sprites for the hero going up, the sprites for the hero walking left, going down, and walking right. Great, let's save this. And let's create a new folder. Let's call it sprites, because I like to have everything organized. You're gonna see this recurrent in the series. I always organize stuff like that, and I highly advise you to do that, because once the project grows, it's very easy for you to lose something and have no idea what that is. So two things: naming conventions and foldering structure are very important when you're working with any project inside of Unreal Engine. So we have the texture, but how do we get the little images that we have here called sprites out of this texture? If you right click on your texture, you go to sprite actions and extract sprites. Create sprite will create a sprite exactly of that image, which we don't want. We want to extract those sprites. So let's go to extract sprites. And this is the extract sprites interface. Now, when you first extract sprites inside of the engine, it's going to try to frame each sprite to the dimension, to the bounding box of the image, and it does a good job. But for flipbooks or sprite animations, we want these to be of the same size, or else they're going to start jitter around. So instead of going for the auto sprite extraction, I'm going to go to grid. And I know, because I created the image, that every sprite I have here is 64 by 64. So in the cell width and the cell height, I'm going to change these to 64 by 64. And before I extract, there's some there's some empty cells here, and it's because I wanted to have the sprite sheet texture as a power of 2 for compression, for optimization, and all that stuff. So when we extract, we're gonna be removing these empty sprites. So click on extract, and it extracted all the sprites. So as we said before, let's delete these ones. And now we have all the sprites we need for the character. And I created a sprite folder for this specific reason, so we can move them into the sprites folder so it doesn't bloat up our content folder. So let's create a new folder, call it Flipbooks, and you're gonna see in a second what that is. So if I go into sprites and select all the sprites of one specific orientation, and let's start it with the ones going down. So we pick the first one to the last, right click, create flipbook, and let's call it FLB for flipbook underscore hero walk down. Now, if I open it, you can see this is an animation that plays all these frames, all these sprites in sequence. And if you want it to have a more like a jittery feel or more a smoother feel, you can go into the frames per second and change that. So we can say like 8, and it gives us this kind of like old school JRPG animation style, but I prefer to keep it at the default of 15. So let's create the same for all the 4 orientation. So this is FLB underscore hero walk up. Now this one, FLB underscore hero walk left. And lastly, create a flipbook FLB underscore hero walk right. Now let's take these and drag them into the flipbook folder we created previously. Move, not copy. And now we have the hero has the flipbooks, the sprites, and it has its own texture for the walk. Great so far. So we've imported the images, the sprite sheet, we extracted the sprites, and we created our flipbooks. Now let's go back to our blueprints folder in core, and let's go into JRPG character. Now, when you open the JRPG character for the first time, this is how it's going to look like. And it has a capsule for the collision, an arrow for the direction, the character movement component, and the sprite. So sprite, it's looking for a flipbook. So let's grab the flipbook for walking down. Now I know it's going to be facing this direction, so let's rotate him. And since it's a flipbook, you can see it on both sides. And let's scale it up so that it fits our capsule. Let's turn off the snap mode. And this is about right. Let's go back to perspective. And now this is our pawn. So if I drag it into the world, this is how our character will look like. And this is basically the style we're going for. So far, so great. But if I play now, why is it that I don't see it? Actually, if I press F8 to eject, it is there. But since the pawn itself has no camera, you basically cannot orient or place the camera where you want it to be in game. So we'll need to create one, and it's very easy. We'll open the JRPG character, open blueprint, go into viewport, and we're going to add 2 components. The first one, and I'm going to parent it to the capsule. So the first one is going to be a spring arm. And the second one, parented to spring arm, is going to be camera. And now I have my spring arm, which I can move, and my camera will move along. I can rotate. And instead of making it further away by doing this, there's a nice property on the spring arm called target arm length. So instead of having it at 300, let's do something like 800. These values you're going to have to tweak for your preference. So if you play now, we can see our character, right? Amazing. And it's because we have a spring arm and a camera. Great. Perfect. So we have set up our character, our player controller, our game mode, and we've imported our sprite sheet, we've extracted the sprites and created the flipbooks. But the character really doesn't move now, right? So if I press WASD, nothing is working. It's because we haven't set up the inputs yet. So let's go and create new folder. Let's call it inputs. Let's create a new folder, call it actions. And we're gonna create our new blueprint action. Now, blueprint actions are more like, what kind of data am I getting when I press any button kind of thing. So if you go into input action, and let's go IA as a prefix for input actions, and let's call it move. In IA underscore move, what kind of data do I want to get? I don't want to get a bool because bool is true or false, so either pressed or released. Since I'm going for movement, I want a two-axis vector. So I'm going to switch it to axis 2D or vector 2D. Now that we have our input action, we need to also create something called input mapping context. So IMC underscore, let's call it move as well. And here is where we're gonna be mapping our input action to the keys we're gonna be using to move the character. So if we open this, you're gonna see that there's a default key mapping. I'm gonna add mappings, and it's looking for an input action. And since we created only one, you can only see this one. So let's add IA underscore move. And here we're going to be adding all the different bindings, keyboard bindings, to this input action. Now, one nice trick in Unreal is that if you press on this keyboard button, you can press on it and then press whatever key you want to bind to. And if I press D, it directly looks for it instead of me looking for the button in the dropdown. Now, if I open this, you'll have triggers, modifiers, and do not worry about the rest. We're going to be focusing mainly on modifiers today in the session. And modifiers are what do you need to add to this keyboard binding to do other stuff. Anyway, so for this context, I'm going to consider D to be positive on my x-axis while A is negative for the horizontal movement, whereas W is positive and S is negative in the forward movement. So right vector is D, forward vector is W. So for the right movement, we don't need to enter anything or add anything. But if we add the left movement, which is A will need to take whatever input is inputted for the horizontal movement and negate it because it goes on the other side. So modifiers, we're going to add a new one. I'm going to go for negate. So now D is going to give me 1, while A is going to give me -1. Now for the up and down, it's slightly more trickier because we're going to add a new modifier. So let's start with W for up. So for the y-axis, imagine that this button with this button combination, if you want, whatever I do technically is going to always be on one axis because it's only one value. It's not like it has x and y. So it's -1 to 1. But if I want to shift that to be on the y-axis, so shift all those values from x to y, we need to add a modifier called Swizzle. Swizzle input axis values. and it's swizzling to y. So that means x will turn into y. And since w is forward, I'm not going to add a negate to it. Well, let's add one last one, and let's add yes, which since it's going to be negative and on y, will need both modifiers, which are going to be the swizzle and the negate. So that's more or less all you need to know, all you need to do in order to do this. Next, we're gonna add this enhanced input component, or this input mapping context, to the player controller. So let's go to our blueprints for controller, and on begin play, I don't want the event tick, we're gonna look for the enhanced input subsystem. This one. And we're gonna map this context to it. So we're gonna add a mapping context to this controller. And the mapping context is the one we just created. Compile and save, and that's all you need to know and to do in the player controller for this to work. Now, priority, we're going to go over it later on. But if you have two mapping contexts that have a mapping on the same button, the one with the higher priority will trigger instead of the other. This is just a side note. Let's go back to JRPG character, and I want to create a function first. Let's call it move. So move will take the x and the y values. So both are going to be float. I'm going to call it x-axis and y-axis. And I'm going to add movement input. And I'm going to get the controller rotation. So get control rotation. I'm going to split this so I have access to x, y, and z. And from the control rotation, I'm going to get right vector. And I don't need to pass the y, just need to pass the x and the z. And this is going to be the world direction for this one. And we're going to add the x-axis to the scale value. So basically, this is the direction and the value. So since it's on x, so left and right, this is going to be either -1 or 1. And this is going to be the direction. Next, for forward and backwards, we're going to be doing more or less the same. Get the control rotation, but now we want to get the forward vector. And we're going to split this as well. And we're going to add just the z to the z, hook it up to the world direction, and get our y-axis. Let's organize this a bit. And our move function is pretty much done. Now in the event graph, we don't need all of this. We can just right click and look for IA_move. And IA_move has an action value. If I split this, you'll see that I have access to the x and the y. So let's drag this function here, call it on trigger, and pass the x value and the y value. Now, if everything is fine and we did everything right, this should be good. So perfect. So now we have a character that has a flipbook animation, and we've added the enhanced input component to go left, right, up, and down. And notice something, you don't need to do extra math to go up and left, for example. So if I press W and A at the same time, it's going to go into that direction. So thank you all for watching, and do like and subscribe. It goes a long way. And in the next video, we're going to be going over actor components, which are components you can attach to any actor. And we're going to be creating our first actor component, which is going to be our animation state actor component. Thank you so much. See you next time.